Statistics can help us make sense of data, and nothing makes data easier to understand than a well-constructed graph. Graphs make patterns and trends in a set of data easier to identify and understand, and they can help us interpret how the data in a set is distributed. This is the third part in a series on summary statistics, so if you haven't seen the lessons on central tendency or variation, you might want to watch those first. When you're looking at a collection of data, it can be useful to organize the values using a frequency table like the one shown. A frequency table establishes several ranges of values that the data might fall into, called class intervals, or bins. You can think of these like physical bins that you might sort the data into if you could physically separate the data values with your hands. Instead, the data is sorted into the table, and next to each class interval you report the number of data values that fall within that range. In this frequency table, there's one data value that falls between 0 and 5. There are two data values that fall between 6 and 10, and so on. Frequency tables can be a helpful way to begin to organize and sort data values, and they can also be useful if you plan to graph your data using a histogram. A histogram is a common data distribution chart used to show the frequency with which specific values or values within ranges occur in a set of data. This histogram represents the data found in the frequency table on the previous slide. By looking at the data in graphical form, it's obvious how the data is distributed, with the greatest number of data values near the middle and fewer data values at the high and low ends. Like in the frequency table, large sets of data are often divided into a limited number of groups. These groups are called class intervals, or may also be referred to as bins. The number of data elements in each class interval is shown by the frequency, which is indicated along the y-axis of the graph. Let's create a histogram to represent this data set. From this example, we'll break the data into ranges of 1 to 5, 6 to 10, and 11 to 15. We'll place labels on the x-axis to indicate these ranges. Again, these ranges of values are referred to as class intervals. We've also reordered the data to make it easier to divide into the ranges. The height of each bar in a histogram indicates the number of data elements or the frequency of occurrence within each range. Now looking at the data, you can see there are 3 data values in the set that are in the range from 1 to 5. There are 4 data values in the range 6 to 10. And there are 2 data values in the range 11 to 15. Note that you can always determine the number of data points in a dataset from the histogram by adding the frequencies from all the data ranges. In this case, we had 3, 4, and 2 to get a total of 9 data points. This histogram represents the length of 27 nearly identical parts. The minimum measurement was 0.745 inches, and the maximum length measurement was 0.760 inches. Each data value between the minimum and maximum fall within one of the class intervals on the horizontal axis. The bars are drawn to show the number of parts that have a length within each class interval, the frequency of occurrence. For instance, of the 27 parts, 2 have a length of 0.746 inches. 4 have a measured length of 0.750 inches. Another way to represent data is a dot plot. A dot plot is similar to a histogram in that it shows frequency of occurrence of data values. To represent the data in the table, we place a dot for each data point directly above the data value. There's 1 dot for each data point. Dot plots are easily changed to histograms by replacing the dots with bars of the appropriate height indicating the frequency. If a line is used to roughly trace the height of a dot plot or a histogram, the line usually takes the shape seen here, known as a bell curve because of its bell-like shape. When a set of data produces a bell curve, we would say that the data is normally distributed or has normal distribution. Knowing whether our data is or isn't normally distributed can tell us a lot about our measurements. and may be very informative for designers and manufacturers who are monitoring their products and systems for quality. Data analysis programs like Microsoft Excel and Google Sheets have some helpful built-in tools for analyzing data and producing graphical representations of a data set. To find out how, check out my video, Statistical Data Analysis in Excel. In part 4 of this lesson, we'll learn about the empirical rule, and we'll see how graphs like histograms and dot plots can be used alongside other summary statistics like the mean and the standard deviation to tell us even more useful information about a data set. Part 5 will discuss how statistics can be used to monitor precision and accuracy in engineering. Thanks for watching.